So first of all, you should get the clarity regarding when we have to apply permutation, when we have to apply combination, or is the difference between both. Many people, when we ask the what is permutation combination with the intermediate or +2 knowledge, people will say permutations means arrangements or combination means selections. Many people have that outline idea. Okay, when what is permutation, what is combination when we ask, many will claim that permutations means arrangements, combinations means selections. But one small correction everyone should know is, yeah, combinations is for selection or choosing agreed, but permutations is not only arrangement actually, it's selection plus arrangement. Everybody keep in mind permutations means selection plus arrangement both happening. The difference between both is arrangement, we can say. Why is that? Then why in +2 we came to know permutations means arrangement means that's the difference. That's the unique feature. Permutations, the extra feature is arrangement. In both selections is happening. Why I'm stressing that word is when you see the question, when there is a word like select or choose, people are applying combinations. Because sir, I know selection or choosing means combination. But guys, you please understand when there is a word selection, still you can apply permutations because permutations is having selection plus arrangement. So what is arrangement here? Arrangement means you are giving some position. You are letting some position. Let us say we have, suppose I have 7 people. I need to select 2 people, one for captain, one for vice captain. I have 7 people. I need to select 2 people, one for captain, one for vice captain. Many people will think that as there is a word selection, you may apply 7C2. It's wrong. Answer is 7P2, not 7C2, 7P2. Out of 7 people, I need to select 2 people for captain and vice captain. I'm giving the position. When I'm giving the position, we have to go for okay permutations. So there is a word selection here. Permutations obviously have selection as well. That please understand. Many will apply this in a wrong way because of the only thing. Okay, they are not understanding that permutation is involving selections as well. Right. So then when we have to apply combination, I want to select 2 people out of 7. If I stop there, then you can apply 7C2. Out of 7 people, I need to select 2 people means then write 7C2. Or I have to choose 2 people out of 7, then write 7C2. Okay. Because there I said only choosing or selection. But if I add one extra line, 2 people for captain and vice captain, or president, vice president, or 3 people, president, vice president, secretary. If I mention some positions, then automatically permutations will come. This is all regarding applications where you need to apply. And there are situations where you should not apply permutation combinations, but still people are applying that. There are some situations where you should not apply. Where to apply, just now we are discussing. When there is choosing or selection, you need to apply combination plus arrangement if they mention. They given any position, then you have to go for permutations. Fine. When we should not apply these two, sir? When repetition is there, keep in mind going forward also, I'll tell you the same. When repetition is there in the question, NPR, NCR is not applicable. NPR, no. Both are not applied directly. Directly, I cannot apply when there is repetition allowed. In any question, if you sense there is a repetition, then NPR, NCR is not applicable. Means I cannot apply permutation, I cannot apply combinations. Both are not allowed when there is a repetition in the question. Okay. Now, what is the outline we are going to discuss in this permutations and combinations is first thing regarding factorial, because every question involves factorial. Well, going forward, we'll involve so just 10 to 20 seconds regarding factorial. Then principles of counting. In permutation, combination, probability, when there is a word and, we should do multiplication. R means addition. Why that? We'll discuss that also. Okay, principles of counting, factorial, and how we got NPR and NCR formula. I generally say I don't recommend to apply the formula. I just want to make sure how NPR formula developed. You people know NPR formula something like n factorial divided by n minus r factorial. NCR means n factorial divided by n minus r factorial into r factorial. Why that formula? How we got that formula? We'll derive with simple basic example. And then you realize that there is no need of formula in any question. Going forward, no need of any formula, you can understand. Once you develop the formula, no? If you have that knowledge, then you can solve any question without formula also. Right. Then permutations, then circular permutation. There is one more thing called invertible circular permutation. Many people know circular permutation only, but there is one more area, invertible circular permutation, and then combinations. Combinations already video available, okay, but these 5 things we need to cover. Factorial, fundamental principles of counting, NPR, NCR formula, permutations and problems related to that. Circular permutation, problems related to that. Invertible circular permutation, problems related to that will be discussed. So basic thing regarding factorial, everyone should aware of is n factorial. What is n factorial formula? N into n minus 1 into n minus 2, so on up to 3 into 2 into 1. And very special case is 0 factorial is nothing but equal to 1. And this is applicable only when n is non-negative integer. If it is negative, minus 5 factorial is not defined. Minus 5 factorial is not minus 5, minus 6, nothing like that. There is no formula factorial for negative values. And if it is decimal value also not allowed. 5.2 factorial, no. We want integer, that too non-negative integer. So why can't you say positive integer? 0 is neither positive nor negative. 0 factorial is also there. So we should say non-negative integer. N must be non-negative integer, and everyone know n factorial is n into n minus 1 into n minus 2, so on up to 3 into 2 into 1. Right. So that's it. Factorial, basic, 0 factorial equal to 1. That's very important. Everyone should know. We'll start from the basic there. We don't want to directly go and attack the question. But at the end of the session, I strongly say that you people can solve any type of question. You will get the basic idea how to handle it in permutation combination. There is no doubt. But listen, focus. For every minute, you need to focus what is happening. You understand. Any doubt at any point of time, let me know. We'll discuss. I don't want to go directly with the formula. We'll go with the nature of the question. I'll use next onwards nature of the question. We have to read the question, understand what type of question it is, then we apply. Don't buy at any formulas. Okay. Now, principles of counting. Okay. In your probability subject also, in your academics, you people can see when there is a and. When they use the word and, we should apply multiplication. When R is involved, we should apply addition. And is there. When and is used, we should apply multiplication. When R is given, we should apply addition. Principles of counting. Now you may have a doubt. Why that's it? Why we have to do multiplication? Why we have to do addition? That's why we are giving with example the justification. Going forward, when there is and m ways, then suppose you need to move from Hyderabad to Mumbai. There are different ways, maybe. Okay, in this way, this okay. If you go via this, there are 2 ways. Via Bangalore, there are 3 ways. Via maybe Maharashtra, there are 2 ways. Something like they'll give different ways. So if it is R, if it is and, how many things you have to apply? That's what thing we are going to understand with example. But keep in mind, when there is and, we have to do multiplication. R means addition. Why, sir? You see, this is the outline. See the example here. I have 2 different fruits and 3 vegetables. 2 different, distinct means different. 2 different fruits. I am calling F1, F2. 3 different vegetables, V1, V2, V3. First question here is, in how many ways? We need to pick 1 fruit and 1 vegetable. 1 fruit and 1 vegetable. Right. So, here how many fruits are there? 2. How many vegetables are there? 3. Among 2 fruits, we need to select 1. Because they said 1 fruit. Among 3 vegetables, you need to select 1. Here also 1 fruit, 1 vegetable, 2C1, 3C1. But here multiplication, here addition. 2C1 means 2. And that calculation we will see next. Keep in mind NC1 is nothing but N. I'll let you know how we got that later. 2 plus 3 is equal to 5. Here 2 into 3 equal to 6. But many people have a doubt why you are doing multiplication when there is and, why it is mandatory. Why you are doing addition when there is r. Now we'll give that justification. See, fruit and vegetable means I can go with the combination f1 v1, first fruit, first vegetable, f1 v2, f1 v3, fruit and vegetable. F1 V1, F1 V2, F1 V3. Next is F2 V1, F2 V2, F2 V3. Total how many? 6. That you got by 2 into 3, 6. Then understand it's not 2 plus 3, it's 2 into 3. Multiplication is involved when and is given. Right. So what about here addition? They said two fruit, either fruit or it may be fruit or vegetable, only one among that. If I select F1, I should not take any other thing. If I select F2, I should not take any other thing. Because either means only one among that. If I select V1, I should not take anything. If I select V2, I should not take any other thing. V3. Total here how many? 5. That's why 2 plus 3, 5. Whereas above one, 2 into 3, 6. Multiplication. So this is the outline you keep in mind. When there is and means multiplication involved. R means addition involved. Got the clarity? Because this is very basic, I am starting, but going forward, all these basics will add on. So, factorial, fundamental principles of counting completed. Now, I'll show some cases as already we discussed, where to apply permutation, where to apply combination. I'll give you one situation, you let me know whether it is permutation or combination for that example. Can you decide? I'll show the example. What to apply in that you have to understand or you have to give me the response. Whether it is P or C. P means permutation, C means combination. You decide for the given example. I'll display it now. So when to apply permutation? Selection and arrangement. Some position is given. If it is combinations means only selection required. Right. Now I'll display the cases. Now what about this scenario? First one. That's why I requested you people to sit bit front to have a better visibility. A team of 8 basketball players need to choose a captain and a co-captain. Now here permutation or combination. Many people think about choose and applying combinations. No, it's permutation. Permutation is having selection and arrangement. Arrangement means giving the position. See, out of 8 people here, first I have to select 2 people, means combination. Then I am arranging the 2 people, one as a captain, one as a co-captain. Arrangement is happening. Selection and arrangement both are there means we should apply permutations. Actually, 8P2 is the answer for that. 8P2. Out of 8, you are selecting 2 and arranging 2. 8P2. Next one. 45 applicants, we need to choose 3 applicants. Combinations 45 C3. 45 C3. So it's a big value. Calculations I'll give you next. Very easy. Any calculation how to do very easily we'll discuss. That's not a big deal. No formulas required. Next one, third one. Batting order for 7 players on a 12-person team. So 12-person team in cricket. Now IPL you can see when impact player. So we can think like 12-person team. Right. So yeah. What about this permutation or combination? Permutations. Out of 12 people, I need to select 7 people. Batting order is first who should come, second who should come, third who should come, who should play. We are giving that arrangement. Selection arrangement involved, then by default we have to go with permutation. So first one 8P2, second one 45, third one 12P7. Now fourth question here, 10 students want to elect a president, vice president, secretary and treasurer. 10 students want to elect a president, vice president, secretary and a treasurer. Permutation or combination? Permutations. Position is giving. Indirectly, out of 10 people, you need to select 4 people and you have to arrange them. One as a treasurer, one as a president, one as vice president, like that. So it's a permutations only, not combination. First, I want to give that clarity for you. Many are doing that blunder mistake. Now, sir, previous question you said 45 applicants, 3 people to choose. Now, 15 applicants, 4 jobs are there. But again, out of 15, I need to select 4 people. One as a testing engineer, one as a manager, one as a system engineer, one as a computer programmer. This is also combination. Next one, 45 people are going to run a race. Gold, silver and bronze. Combination or combination? Permutations only. Permutations. Why, sir? Among 45, 3, first person gold, silver, you are giving position. Simple logic, position is given. Position is given. If they say simple 3 medals, for 45 people, 3 medals to be given, then okay, combination. 3 medals. They're not specified, but here they specified. Specific position is mentioned. When you are putting order or position is given, you have to go for permutation. So then when to apply combinations? So see, out of 6 cases, you given 5 cases permutation only. Then where to apply combinations, sir? See, combinations we can apply in a number of applications, like applications I'm talking. When you want to decide how many number of triangles, they'll give some points. Okay, some points will be given. How many triangles will be decided by combinations? How many number of diagonals in polygon will be decided by combinations? How many number of straight lines will be decided by combinations? How many number of handshakes? There are a lot of stuff related to combinations also. Number of handshakes, number of matches, and lot other you can see in combinations. When we start combinations, so we will get that. But our outline is what? First, what we are discussing? We are discussing permutations, then circular permutation or invertible circular permutation. Then we are going for combinations. First, we are discussing about permutation. But before that, I just want to trigger your minds how we got NPR formula, NCR formula. NPR formula, NCR formula, what you people know long back. How we got it, I am just want to develop, but I don't want to use anywhere going forward. I am not using those formula anywhere, but just for your idea how the formula developed. Okay, if you understand that, then maybe some clarity you will get regarding what I called selection, and here selection and arrangement. This is plus, okay, it's actually and selection and arrangement, not plus. Plus means again you may be wrongly interpreting that. Selection and arrangements. Selection and arrangement. Extra. Now, okay, see this basic example. From this, we'll develop the formula. Permutation of 3 elements out of 5 distinct elements. General notation is 5p3. Why 5p3? Out of 5 elements, we need to do permutation for 3 elements. Right. Now, see the practical scenario. We have A, B, C, D, okay, E. A, B, C, D, E. Right, so 5 things. Now, among these 5, what is our job is we have to select 3 and we need to arrange them. Means actually there are 3 places. That's what, right? There are 3 positions available. We need to fill those 3 positions. That's what we got the idea. There is one question we discussed. There are 10 people. We need vice president, president, secretary, treasurer. Means among 10 people, I need to fill the 4 positions. So I have to select 4 among them and we have to arrange them. Right? See here, for this position, you can start from right side or left side. It's your wish. For this position, okay, how many candidates are waiting is 5 people. I'm selecting, sir, how permutations is having selection? You feel at least here. Out of 5 people, I'm selecting 1 person and I'm arranging that person here. 5 chances for that. I'm selecting one among A, B, C, D, E. I'm selecting 1 person among that 5. It can be A, it can be B, it can be C, it can be D or E. That's why 5. Let's say B gone. I arrange it here. Now how many are available? 4. Among the 4 persons, I have to select one person. It may be ER, AR, CRD. I'll put this place here. Some people argue, sir, fill the right side. Okay, your wish. Because A into B or B into A will be same. Next. Okay, now let us say E is gone. E arranged in this place. Now how many are available? 3 people available. Among those 3, I need to select one person. I need to fill this. So 5 into 4 into 3. Answer is okay, 60 fine. But I said I want to develop the formula. Guys, if you know 5 into 4 into 3, sufficient. Any question can be solved. But for your idea how the formula developed, no? You multiply numerator with 2 into 1, denominator with 2 into 1. Then what is numerator? 5 factorial. Can I write denominator as 2 factorial? I am developing the formula. Actually, our task is completed. Answer is 60. Our job done. But we are just figuring formula. See, I can write denominator 2 as 5 minus 3. And this is how your formula. I hope you got the idea. What is NPR formula? NPR is n factorial divided by n minus r factorial, provided n is greater than or equal to r. That's a basic sense. If I have 10 people, selecting 15 people is not possible, right? If I have 10 people, I want 15 people, means it's not possible. That's why n should be greater than or equal to r. The total number of people should be more. N should be greater than or equal to r. If I have 10 people, I can maximum select 10 people only. I cannot select 15. This condition, n should be greater than or equal to r is required. So this is the formula. NPR equal to n factorial divided by n minus r factorial. And how you got that is just this is the simple logic they'll apply. Don't go for okay in our plus 2 there is 2 pages explanation for formula, not required. You take one example, you got some answer, from there you modify, you will get the answer, things. Why we need to go for 2 or 3 pages, some theories and all, not required. It's basic. Right. Sir, then what about combination, sir? We'll see how we got the formula for combination. So right now you are clear with NPR is nothing but n factorial divided by n minus r factorial. Right. In some questions, there is a sentence like arrange 5 people. See, arrange 5 people. If it is there, means it's a permutation. So arrangement is involved, means it's permutation. Arrange 5 people means listen. Many people have a doubt, sir. 5 people if there. Arrange 5 people means among 5 I need to select 2 people and arrange, or 3 people select and arrange. What to be done, sir? We should take all at a time by default. When they say arrange 4 people means 4 people you have to take. All four P4. Arrange 5 people means we should take 5P5. Take all at a time by default. Take all at a time. They say arrange 5 people. We have to select 5 and arrange all 5. Some people may have doubt. Everyone have a doubt actually. Arrange 5 people means among 5 people. I need to select 3 people and arrange. Or I need to select 2 people and arrange. Or I have to take all 5 or not. We have to take by default all at a time. All 5 people you have to take and we have to arrange all 5. 5P5. So what is 5P5 means? Formula you ignore. Okay, basic thing. Okay, is like see we have A B C D, 5 slots are available, 5 slots are ready. Okay, you have 5 people, let's say P Q R S T. Then what can be done for first position? 5 persons are waiting. For next position 4, for next position 3, for next position 2, for next position 1, which is nothing but 5 factorial. So keep in mind NPN is nothing but n factorial. NPN is nothing but n factorial. NPN arrange 5 people means we have to take all 5 people at a time and we need to apply that. Regarding calculations, regarding calculations, what to be done is very simple idea, calculation point of view. NP1 means we have to write only one term, N. NP1 means write simple one term, N. NP2 means two terms I have to write, two positions are there, right? NP2 means two slots are there. First slot N, next slot is N minus 1. Simple. NP3 means three slots are available, N into N minus 1 into N minus 2. So calculations are very simple. If they ask 7P2 now, what we have to do 7P2 means? Formula not required. What is 7P2 means? Two terms we have to write. 7 into 6, 42. That's it. If it is 8P3, 8 into 7 into 6. Three terms we have to write. No need of actually that's what I'm telling you. I don't want that formula. NPR formula n factorial upon n minus r factorial. We're not going to apply anyway. That is only for your understanding how formula is developed and why they use a lot of formulas long back. But this is sufficient. Now, what is NP naught? NP naught. Zero players are available, right? So only one way. Or you can apply the formula. One thing is that our common sense is there are 10 people. You need to select 0 people and you have to arrange 0 people. It's only one way. Means all people you are sending out, rejecting. Have 10 people. Okay, let's say 10 P naught. 10 P naught means out of 10 people, you need to select 0 people and you need to arrange 0 people. Means I need to reject all people. It's only one way. Why one sir? Why not 0? Again, that's why I'm telling you. All 10 people I need to reject. That's also one way. That is also one way, one method. Rejecting all people also one method. Selecting all people also one method. Selecting only one person out of 10 also that's one way of. Right. So here I'm rejecting all. That's one way. Right. NP not equal to 1. See, don't try to, that's what, don't try to bahat, sir, NP not 1, NP not. Understand what's that NP not meaning. I'm clearly mentioning selection and arrangement. Selection, you see in that direction, no? Then no need of formulas and all. How NP3, sir, again, no need to add the formula. NP3 means there are 3 slots available. NP probable, first N, then 1 down, N minus 1, then 1 down, N minus 2. If repetition is there, well, then what we can do? So that's what I said already. When repetition is there, permutation combination not applicable. If repetition is there, suppose same candidate again repeated, same digit I can use again means NP3, NP, no, we should not use that notation. NPR, NCR should not be used when there is repetition involved. That you will understand slowly. Next thing is regarding combinations, how we got NCR formula, right? What is permutations? I said in the first slide, first concept introduction. Permutation means selection and see that only one word we are repeatedly close to 50 times we repeatedly said so far. Again, I am using the same thing. Okay, selection and arrangement. NPR is nothing but NCR and means additional multiplication. Multiplication. Here I have to arrange R people. Whom you selected, those people you need to arrange, right? I selected how many people? R people. I have to arrange R. Arranging R people is nothing but arranging 5 people is what you got. 5P5, 5 factorial. Arranging N people is NPN, N factorial. Here R people means. So this is why NCR is nothing but NPR divided by R factorial. NPR formula you people know. Put that this is what the formula you see in your textbooks. NCR is n factorial divided by n minus r factorial into r factorial. N factorial upon n minus r factorial into r factorial. But again, I am telling you, I don't want to apply this formula also. We'll see okay, how the basic calculations can be done now. NCR is NPR divided by R factorial. Permutation is selection and arrangement. From that, we develop the formula. So then what about 7C3? How to calculate, sir? How to calculate 7C2, sir? 7C5? How to do that? Yeah, fine. Your background mind, okay, you should always think about this point. NCR is nothing but NPR divided by R factorial, right? Okay. Now see, I want NC2 means n into n minus 1, two terms in numerator, divide by 2 factorial, that R factorial in denominator. NPR divided by R factorial, that extra is there R factorial. So NC2 means two terms in numerator divided by 2 factorial. NC3 means three terms in numerator divided by 3 factorial. Right now, very important. What is NC1? N by 1, as per formula wise, okay. N divided by 1 factorial, or else basic thing. 10 people attended for interview. I need to select only one person. Let us say 10 people A, B, C, D, E, F, G, H, I, J. These 10 people attended for interview. I have to select only. I can select A, or B, or C, or D. R means adding. I can select A one way, or B second way, or C third way, or D fourth way. Left R means adding, adding, adding. Totally we'll get up to J 10 ways. That's why NC1 is nothing but N, NC1 is nothing but 10. NC not means out of 10 people, I'm not selecting anyone. One way. Rejecting all people. Rejecting all people also one way. NCN is what then? 10 people attended interview, I am selecting all the 10. Only one way it is. I have to select, there is no other choice. 10 people attended for interview, I have to select all 10 people means I have to give offer to everybody. There is no choice for me. Only one way it is. 10 people came, I have to select all 10 people. It's one way. Try to don't go for formula. You can apply here, you cancel and you will get same answer. NCR is NPR divided by R factorial. NCN means NPN divided by N factorial. NPN means N factorial only. Cancel will get 1. But sense it. Better always avoiding the formula. You can sense it easily. Now I want 7C2. 7C2 means 7 into 6 divided by 2. Next onwards, no. You can directly give the value as the answer. That one step you need to do in your mind to write the answer. What is 8C3? 8 into 7 into 6 divided by 3 factorial means 6 cancel 8 into 7 56. 8 into 7 into 3 divided by 3 factorial which is nothing but 6 get cancelled 56. 56 is the value, right? Now, sir, but in this model, listen, in this model, doing 13C11 is it easy? 13C11 means what we have to write? 11 terms should be there in numerator divided by, is it time taken or not? But listen, everybody focus here. Listen. See, the basic meaning of 13C11 means what? 13 people attended for interview. You need to select 11. Is that equal to 13 people attended for interview? I reject 2 people. Both same, right? Now, what is the advantage of 13C2? Calculation is easy. 13 into 12 divided by 2, which is nothing but 78. How you can say 13C2, sir? Practically, you assume out of 13 people attended for interview, I need to select 11 people. What I'm doing, I'm selecting 2 people, I'm sending them out. I'm selecting out of 13 people which 2 people are very worst, are okay, not disciplined, or maybe not properly maintained dress for attending the interview. I'll see 2 worst people among them and I'm sending them out. Remaining 11 people, that's easy, right? Instead of selecting, doing process for all 13 and selecting 11, I'll select 2 worst people among them and sending them out. It's a bit easy. So 13C11 equal to 13C2. That's what don't, sir, what is this, sir? Actually, if you see, this is what the formula also. NCR equal to NCN minus R. You can find that in textbooks, but I don't want in this way. What I that formula maybe you can remember in a wrong side, okay, but what I'll tell you, know, simple. Selecting selecting R people equal to rejecting remaining people. Select R people or reject remaining people, both same. Out of 13, 11 people selection, remaining people means 2 only. Rejecting them is same. That's easy. Don't see in formula mode. Next time you may write instead of n minus r something else. N minus r c and some people will write formula in a wrong way. So don't bad the formula. You just see what the meaning. Selecting r people is nothing but equal to, okay, rejecting remaining people means n minus r. Out of n I am selecting r. Remaining means n minus r only. I am rejecting them. Both are equal. Okay, just I can give the list of formulas. You apply this, you apply that. That's not the nature. That's don't go in that way. Right. Then you may have a doubt. Adding these two, you got total n. You can try that. R and n minus r. Adding what? R get cancelled. Total equal to n. Adding those two, total should come. That's why selecting and remaining I am calling. Rejecting remaining. Select R, rejecting remaining. Adding should give the total obviously. Here also 11 plus 2. 13 should match, right? Okay. Now we'll go for the questions. I'm starting with very basic question. From the digits 1, 2, 3, 4, 5, how many 2 digits numbers can be formed when repetition is not allowed? They're asking 3 digit number or 2 digit number. 2 digit number using 1, 2, 3, 4, 5 when repetition is not allowed. Okay. We have 2 slots 1, 2, 3, 4, 5. I can directly say 5p2 because I need to select them and I have to arrange them. 5p2 means 5 into 4, 20 directly, or among these 5 I can put one here, 5 chances, then 4 chances, right? So 5 into 4, 20, like that we can do in this way also. First 5 chances, then 4 chances is the 5 into 4, or 5p2 you can apply that formula also. Repetition not allowed. When repetition allowed, we cannot say NPR formula. I cannot write NPR formula when repetition is allowed. Now, very important doubt everyone should get in your mind is, sir, in question, if they don't mention repetition allowed or not, here what I said in the question, repetition not allowed, clearly I mentioned. But there are some questions, sir, they not mention repetition allowed or not. Then what we have to do, sir? Guys, keep in mind there is one basic thing, nature of question concept. What is nature of question, sir? First see the question. Let us I'm giving you very basic point now. Nature of question. Okay. If it is 3-digit number, let me know 3-digit numbers. Few examples of 3-digit numbers, please. What are 3-digit numbers? Yeah. 3-digit numbers. 100. Okay. 940 or 420. All these are okay. 555. All these are 3-digit numbers or not? Right. Now listen. When in question they not mention repetition allowed or not, the nature of 3-digit number is 100 allowed, 555 allowed. In 555, digits are repeated. Means repetition allowed. In 100 0 is there. Repetition allowed. Okay, by default, if not mentioning the question, you can consider repetition. I'm writing REP tick mark means repetition allowed. And by default, you should understand 3-digit number cannot start with 0. Start with 0 is not allowed. This is applicable for 4-digit number, 5-digit number also. For 4-digit number also, we know, okay, 1000 is a 4-digit number where zeros are repeated, means repetition is allowed. If they don't give any conditions for you in the question, default repetition allowed is what you have to take. Why that argument? That's what I am giving the clarity. By nature, the question is having that, the number is having that future. Second thing, 3-digit password Now tell me for password. Okay, you have a ATM pin. Can you go for 0000 as password? Is it allowed for ATM pin? Whether it will accept or not? All zeros. Password 023. 3-digit password. Accepted or not? Accepted. In any question, when they mention password, no need to say it can start with 0. Yes. 3-digit number cannot start with 0, but 3-digit password can start with 0. That's the point. Where many people will do the wrong. When is 3-digit password? No, again people will do 1 to 9 only allowed, sir. No, 0 to 9 is allowed. And repetition allowed. Password actually, yeah. You can take 2222 password. 997 and password. You can take 9966. You can take it's accept. It will accept. ATM will accept that pin password. There is no problem. Or else you have a suitcase with numbers, digit password. Yeah, it will take. Or by default in general, I think you know many mobiles, old mobiles also default password is 000. 4 zeros is the default password to reset those settings and all. Right? So yeah, password. That's what. Here one point. Repetition allowed can start with 0 allowed. I can't say start with 0 only. 0 is allowed. So this no need to mention in the question. That is what I am calling nature of the question. If they don't give any data in the question, understand the nature of that question. Then apply. Okay, don't bahat. Okay, sir, I taken repetition not allowed. I taken repetition allowed. You see the question nature, then decide. Don't blindly go ahead. Right. Now I'll see the next question. First question, very basic question we taken. I said like we'll start with the very basics. We'll slowly move to the next level. Now my next question is 1, 2, 3, 4, 5. How many two-digit even numbers and two-digit odd numbers can be formed? Repetition of digits is allowed. Now you will see NPR I cannot write. You can see practically, sir. R said long back, repetition is there, permutation not allowed, combination not allowed. Now you can see why the reason. Okay, what is the reason is, yeah, two-digit even number, first one, then two-digit odd number. And my dear friends, see, always try to go for the condition. When you start the question, no, first see the condition position. Even number means I need to see this place. So among 1, 2, 3, 4, 5, even digit, here I can go with two ways only because I can fill with 2 or 4. I want two-digit even number. So I can fill that slot with 2 or 4 only two ways. Okay. Next, what are the total numbers? 1, 2, 3, 4, 5. As repetition allowed, all 5 numbers are available here. Don't say 4 numbers now. Repetition allowed, all numbers are available now. 5 into 2, 10. Now you cannot say NPR formula. 5P2 is 5 into 4, 20. But we got here only 10. Whereas here, what will happen here? Two-digit odd number. Slowly, one question, one condition will be added. Two-digit odd number means it can be filled. Units place is deciding, right? Units place will decide. That's why I'm taking the rightmost place. Rightmost is units place. So here I can fill with 3 ways. I can use 1 or 3 or 5. But for this lot, all 5 numbers are available now because repetition allowed. If repetition not allowed, what will be the answers? Let me know. Same question, first one, second one. If repetition not allowed, first one will be 4 into 2, 6, not 4 into 2, 8, not 3 into 2. Because among 2 and 4, only one number you are using. We cannot use both at a time. There is only one place. Among 2 and 4, one number will be blocked for this place. Still 4 numbers are available. 4 into 2. Here also 4 into 3. 4 into 3. Because among 1, 3, 5, one number will be used here. Remaining numbers are available for the next. 4 into 3, 4 into 2. So every question here onwards, you think about, yeah, if repetition allowed, what can be done? If repetition not allowed, what can be done for this question? How can I handle this? You question yourself for every question, what is the better way, right? Now see the third question. Now both are there, and again we are adding one good point here. How many three-digit numbers can be formed? Actually, can be formed using 0, 1, 2, 3, and 4. If repetition is not allowed, repetition is allowed. Both for the same question. It's not two-digit number; it is a three-digit number. Using the digits 0, 1, 2, 3, 4. It is not three-digit password. Same question, three-digit password means answer again will change. This is three-digit number. For the same question, repetition not allowed, repetition allowed. Now at least we can sense the difference between those two. Initially, we are worrying about what is difference between permutation combination. Now, in permutations, what's about repetition allowed, repetition not allowed, how to handle that. But what will be the first one answer? 3 slots. I said for the given thing where condition is there, go and fill the condition first. Sir, in previous question at least I know the two-digit even number, two-digit odd number, condition is even and odd. For this question, where is the condition, sir? By default, when 0 is there, there is a condition. We cannot start with 0. Three-digit number cannot start with 0. First to go for the leftmost place. Leftmost place cannot fill with 0. First fill that slot. Where to start? That's what you have to know the idea. Condition. So in this question, condition is not given, indirectly given. Whenever 0 is involved in the question, you need to be definitely worry. So first one, 3 slots are there. This slot can be filled in 4 ways. Why? 1 or 2 or 3 or 4 only allowed. 0 not allowed, 4 ways. Okay. Now among remaining 2 slots, it's your wish. Fill the middle one or right one, it's your wish. I don't have any worry. 4 into. Now what is the how many ways for this one? Repetition allowed or not allowed? Repetition not allowed. So let us say 4 is used already. Then what are the numbers available? 0 available, 1 available. Okay, again 4 here, 4 here, 4 you may confuse. I'll say 3 is used. Now numbers available is 0, 1, 2, 4 are available. How many numbers digits available? 4. Then this slot is filled by 2. Let us say 2 is used here. Then for this slot what are available? 0, 1, 4. 3 are available. 4 into 4 into 3, 48. Now repetition allowed. Then what will be the case? Many people, when I say this topic, you people are doing give up procedure. It's not miracle, it's easy only. What can be done? 4 into 5 into 5. Repetition allowed is very easy actually to do. Repetition not only a lot of conditions will come in your mind, but repetition allowed is very easy. Therefore, then why 5 here is all digits are again used. We can use it again and again. There is no problem. See this now 100. There is a difference, huge difference between these two. First one repetition not allowed 48. Now repetition allowed 100. Now you question yourself, why middle one 5, above 4 only? Why rightmost is 5 in below, in above one why 3? If you understand that, then you are getting clarity. If not, ask here and get it clarity. Okay, get the clarity. Otherwise, it's a bit difficult. Moving forward is difficult. It's waste of time only then. You just understand why this 5, why that 5, what is happening. Now this question, no, I given 4 questions internally. Everyone try this. I'll give time. What is the last point? Notice. Use. Is it only once means? Repetition not allowed. Repetition not allowed. Now, 4 questions if you do one by one, you may get full clarity regarding permutation. Now, you get a lot of doubts also while solving. Initially 2-digit number, then 3-digit number, now 4-digit number we entered. That to 4 questions on the same data. 3 must come, 3 never come, 3 will be first digit, 3 must be there but not first digit. So what about first question answer? 3 must come is 60, okay, fine, 60, 360, okay. See, first question, we have 4 slots, 3 must come, right? Using 3, 4, 5, 6, 7, 8, 3 must come is the data. So, one slot is occupied by 3. It can be 3 and this, or 3 will take hundreds place, 3 can take tens place, or 3 can take. So, 4 into I am writing, why 4 into is 3 can occupy 4 places. It can occupy units place, tens place, hundreds place, thousands place. 3 can occupy different positions like 4 places. That's why 4 into. Then, okay, 3 is gone. Then how many digits are available? 3 gone. Still 5 available. How many places are ready? Everywhere 3 ready. So now 5 available. 3 places means 5p 3. So 4 into 60. 5p3 means 5 into 4 into 3, which is 4 into 60. 240 if I am not wrong. Check it out whether it is 360 or 240. 240 is what you see once. Any doubt in this point, please? 3 must come. 3 can occupy. Okay. Thousands place, hundreds place, tens place, units place, all these different places chances is there. So that's what finally 4 into 5p3 we got 240. Next one 3 never comes is easy. So we have how many slots? 4 slots using 4, 5, 6, 7, 8. It's 5p4. 5 into 4 into 3 into 2 which is 120. Second one I don't want 3. I should fill that 4-digit number using 4, 5, 6, 7, 8. I have 5 digits, 4 places. 5 into 4 into 3 into 2 will come. That's nothing but called 5p4. I just giving you the habit of writing 5p4 and all. In fact, it's 5 into 4 into 3 into 2. Because some questions now they'll give options like this format 5p4. You may know 5 into 4 into 3 into 2, but they give in 5p4. You should understand that also. Are you getting why 5p4 here? Okay. Next one. What's the answer? 60. 3 will be first digit. So this slot is booked. Now these 3 slots are available as digits repetition is not allowed. We have 5 digits, 3 places, which is nothing but equal to 60. 3 will be first digit. This is first digit means leftmost. Last digit means rightmost. Units place is last digit. The next one is 3 must come, but not as a means it can occupy hundreds place, it can occupy tens place, it can occupy units place. So 3 into 5p3. What is this 3 meaning? What is that 3 meaning? First 3. Why 3 into 5p3? 5p3 because still 3 slots are available and we have 5 digits 4, 5, 6, 7, 8. Okay, because of that 5p3. Okay, what is that 3? 3 can occupy 3 positions. We can go with okay, hundreds place, tens place, and units place. So 3 places. So 3 into 5p3. Good. Now, any doubt on this, please let me know, or else we'll go for the next level. That's what I'm telling you. Slowly, we'll go for the next level from basic. Any question between doubt, please get it clarified, or else next level we are going one by one, one by one. We start with easy. Okay, you can understand going forward, questions will be bit next level. But you are able to solve because you are in the flow. Now this question, the 3-digit number, this is 5th one. Okay. The number of 3-digit numbers, how many are there? Such that 1 is never to the immediate right of 2. The question is how many 3-digit numbers are there? 1 is never immediate right of 2. 2 immediate right, 1 should not be there. Like that, how many 3-digit numbers are there? 3-digit numbers means from where to where? Starting point 100, ending 999. That among those numbers, okay, how many are not having 1 as immediate right of 2? 1 is never the immediate right of 2. How many such 3-digit numbers are there? That's what you need to count. I hope everybody understands the question, but worry is how to do that. The number of, that's what I am telling you, slowly we'll go for the next level. We are entering into the next level now. How many 3-digit numbers are there? 1 is never immediate right of 2. I'll give a clue. What you can do, Okay, probability of success is 1 minus probability of, what is 1 there? 1 means total probability. Probability of success is 1 minus probability of failure. 1 is total probability overall. Here, 1 is immediate right of 2. You want means among total subtract, okay, number of ways. 1 is immediate right of 2. Number of ways. 1 is immediate right of 2. Now, what is the total? Can anyone say? Total is, I want total. Total numbers. Total 3-digit numbers. Questions regarding 3-digit numbers, right? Out of total 3-digit numbers, yes sir, 899. Okay. Still, many people are manually counting. Sir, you said 3-digit number starts from 100, ending with 999. So you are saying 899. Okay. What is 0 to 9 count? 0 to 9, how many digits will be there? 0 to 9, how many digits? 10, not 9. 900 actually. It's not 9, 8, 9, 10, 900. 100 is also counted. Okay, simple. From 1 to 999, how many numbers? From 1 to 999, 999 numbers is there. Right. Among that 1 to 99 removed, then this will come, right? 1 to 99, how many? 99. From 999, 99 removed means nothing but 900, right? Take 1 as the point. From 1 to 999, from that 1 to 99 removed, then it's nothing but 100 to this. RLC, I told you already, 3-digit number repetition allowed. 3-digit number means 3 slots are there. This can be filled in how many ways? This will be how many ways? First one, how many ways? 3-digit number leftmost. 1 to 9, 9 ways. 0 is not allowed. Remaining places, 0 to 9, all are allowed. Repetition allowed, right? 3-digit number is basically 3-digit number by default. Repetition allowed. You count like that or see directly I got 900 as the total. This is easy, right? Or if you want to calculate manually, that's what I'm showing you. 100 to 999. You calculate everything one number also, you'll get 900. Or else it's simple. Why I'm telling you that is maybe next time they'll ask 4-digit number. Total 4-digit numbers are 9 into 10 into 10 into 10. Why 9? We cannot start with 0 as is a number. If it is a password, then 10 into 10 into 10 will come. That also I need to be careful then going forward, because next question there is a question related to password also given. So fine, okay. 900 is the total. My job is done for this one. Minus, what I have to do now? Number of ways. One is immediate right of 2 in 3-digit number. In 3-digit number, 1 is immediate right of 2 means there are 2 ways like this. Is this one immediate right of 2? Other one is this. One is immediate right of 2. This one only. Here how many ways? Here how many ways? That's it. Question complete. Here what can be filled in that space? Is it one immediate right of 2 or not? Is this digit number or not? Yes. Now how many ways that can be filled? That place. Dash place. 10. 0 to 9 allowed. So I can say 10 ways. Or this is also because of our addition came here. This is also one is immediate right of 2 only. Okay, here 9 only. 1 to 9 allowed. Why not 0 to 9? 0 cannot be first digit, right? So 19. So 1 is immediate right of 2 is 19 ways. So if you remove 881 is your answer. Option C. Total minus. This is next level question for sure, yes. But the basics which is required here is already discussed. What is the total? Total 3-digit number is 900. And what are the mistake you people do? Options available. You can see 891 is there, 881 is there. Because in one question, some people will write only 2-1 blank. Some people write blank 2-1. In the exam, okay, you may read only one among that, then answer will be available with that also. 891 also given. One is immediate right of 2. There are 2 chances. This one and this one. Many people do only one among this and end with wrong answer. So be aware of things. This is a bit next level question, agreed. We should take the challenge. Slowly we are moving to the difficult questions. Next question we are moving. Are you clear with this question or any doubt in this please? Why that 19 subtract? Sir, can't we do directly? See, 800 plus ways doing all things is difficult. We can do directly, but it will take more time. 2 to 3 minutes, it will take time. Lot of cases you need to be cross-checked and all. But this is easy. First thing what you can do now, without 2 and 1, how many numbers can be formed? Or with 2 only, without 1, how many numbers can be formed? 1 involved, 2 not involved, how many can be formed? With 2 and 1 involved, but which not immediate right, how many? Like that, we need to separately count. That will take more time. Right, so instead, this is easy. My next question is this. I think I hope you people can answer this, but read the question carefully. How many integers are there between 100 and 1000, all of whose digits are even? Can anyone tell one example like that? Satisfying that? One example, answer we'll see later. Yes? 246. Yeah, 246, all are even digits. One more. 680. 680, yeah, allowed. Then 222. 222 allowed. All are even. In question, repetition not allowed, not mentioned. Repetition allowed is there. 222. It's a digit number. All are even. It is between 100 and 1000 only. So you have to understand the question, sir. Repetition not allowed. You don't take it that. You don't take by the repetition not allowed if until unless I mention the question. 222 is a number, all even. So repetition allowed. Nature of the question. Nature of the question, we need to worry about that. So, what's your answer? Is it how many slots available? Between 1000 and 100 and 1000 means all numbers are 3-digit numbers only. How many ways I can fill this slot? 4 ways. Superb. 2, 4, 6, 8. Next slot 5 ways. 5 not 8. Only all digits are even here. They are not asking it's a even digit number. There is a different meaning. Even digit number means we will see units place only. But in this question, all digits are even. Every digit should be even. So this should be even, here also even, 0 allowed now. 0 to 4, 6, 8. What about this one? 5. Superb. So answer is 100. See, excellent question. Not typical. Given in GATE exam, you can sense what level. GATE exam, they'll give good level of questions, as there is only 10 questions in GATE from quant reasoning and verbal all together. Only 10 questions. So less number of questions means they'll give good concept oriented things. And see the question they give. 100 is correct. Clear with this? Shall I go for the next one? So far 6 questions only completed. Number of questions is less. Fine. Now this is again excellent question. Many will do blunder mistakes. Thanks to the person who created this question actually. Given question gate. And see the question. Previous question all digits are. This question again given in gate. Previous gate. This is question given in gate. All digits are 3-digit number with all digits. But one extra point they mentioned. No two adjacent digits being the same. Okay. Satisfying this, let me know the numbers. Apart from 137 and 133. 137 is a satisfying one because adjacent, all are odd digits, adjacent is not same. 133 no, because odd okay, but 3 and 3 is adjacent, adjacent should not be same. But my dear friends, here one important note to avoid the mistake, is 313 correct or not? 313. 313. Why this question is very important, you know, this is not repetition allowed, not fully repetition allowed, not no repetition also. It's in between, semi. 313 is okay. Why, sir? All are odd, adjacent are not same. Adjacent are not same. Question is adjacent are not same. If repetition not all, they'll mention that clearly. They said only adjacents are not same. Excellent question actually this is. Again, many will end with wrong answer. Let's learn. When there is a learning, be happy. There is some new point added into our pocket. Happy. How many such numbers exist? Let me know what's your answer. 720 wrong blindly because odd numbers are out of 900. Odd are half only. 450 around. So 720 is blunder. It will be among A, C, D. 60. Okay. Please read the question, understand it properly. Now, 3 slots. Okay. How many ways this slot can be filled? 5 ways. Now, previously 4, 2, 4, 6, 8. But here 5 because 1, 3, 5, 7, 9. Let us see, guys, listen. Let us say I am using 9 here. I am using 9 in this place. Then how many ways can be filled this one? For using 1, 3, 5, 7, 4 ways only. Many are saying 60 is the answer, but the answer is 80. That is why I am waiting. 60 means there is no fun. But 80, why sir? See, here I am using, let us say 5 I am using. Leftmost is 9, middle number 5. Now rightmost, how many ways I can fill this is? 1, 3, 7, 9 is allowed here. My number is okay, 9, 5. Yeah, 9, 5 it can be 1, okay. 9, 5, 3 is okay. 9, 5, 7 is okay. 9, 5, 9 also okay. See the beauty in the question. Lot of people are telling 60, 5 into 4 into 3 means that's what I'm telling you, adjacent not same, but there is a gap. 313, I told you example already. 313 is allowed. All are odd, adjacents are not same. When there is a gap, no problem. So that's what the beauty in this question. Previous question, now this is bit next level to that. Previous one, all digits are even. It's a 3-digit number indirectly. between 100 and 1000 they mention. Here clearly 3-digit number with all odd digits. Okay. With the condition no two adjacents being the same. See the next one. Next question. Again, you have a good update here. First word, read it. What is that? An email password. Nowadays, we know one capital, one small letter, one number must be, one special character like that. Here also they given a question, good question actually again. And again I'm telling you, you will give the wrong answer. I'll wait for 1 minute. I'll check for your answer. Yes. Answer option A 6760. Okay. Any other options from your end? Everybody stick on for A, B, C, D, four different options. Yeah. Answer is that is what I told you before starting this question. Everybody will give the wrong answer and the answer is 40,560. Why sir? Why sir? Listen, listen. Password is how many characters? 3 characters. Read the entire question. Whether they mention you should start with a number, whether they mention you should start with upper character, lowercase. No, you can start with this. That's a 3 factorial. I can start with a number. This slot can be a number, can be a uppercase letter, can be a 3 ways. Next, this can be, let's say this is uppercase, then this can be number or lowercase, 2 ways. If it is number, then this should be lowercase. So 3 into 2 into 1, 6 into internally numbers are 10, 0 to 9 allowed. Password, if I start with a digit also 0 to 9 all are allowed. Then uppercase 26 capital A to Z. Lowercase 26 small a to z. And again, no worry regarding repetition. Uppercase, lowercase is different. In fact, when they not mention password, repetition is allowed. By default, repetition is allowed in password. So 6760 into 6. That extra 6 here. You people are giving 6760 with this case. 10 into 26 into 6. This extra 6 is missing. 3 factorial. This is because of arranging. It can be a digit. It can be a uppercase letter. It can be a lowercase letter. Check it out all those. Mistakes. Yeah, fine, no problem. At least we understand now. We get the update. The password has to contain one numeral. They not mention start with a numeral. Okay, some people give the passwords, email passwords also starting with a number and then characters are reverse. Somebody start with the letter and then at the end numbers. It's all up to you, right? Now this question also one good learning point. Seems very easy question. Wanted like giving no options for you. Let us see how many of you can correct this. How many positive integers less than 500 can be formed using the numbers 1, 2, 3 and 5 for digits, each digit being used only once means repetition not allowed. And please read the numbers carefully. 1, 2, 3 and 5. 4 is not there. Don't be in assumption 1, 2, 3, then 4 and 5. 4 is not given. I given 1, 2, 3 and 5 only. 4 not mentioned. Don't take it that way. But still, let me see how many of you can give the correct answer. I'll wait for that. Less than 500. How many positive integers can be formed using this? Your answer 80. 1 8. Okay. Answer how much? 1 8. See, I am giving you clearly an alert before starting the question, and still you are giving the wrong answer. This in first line. What is that first line? How many? Let me know positive integers example. Is it 5 positive integer? 25 positive integer? Means single digit, 2 digit, 3 digit, right? All 2 digit numbers are less than 500, right? Then why you missed? I am not giving how many 3 digit numbers. I am not telling you that. How many? Single digit is a positive integer. 2 digit numbers. You people are doing 3 digit number only. Here 5 not allowed, sir. 1 not 2 or 3. That is why 3 ways here, sir. As repetition not allowed, let us say 2 is used here. Then here 1, 3, 5 available, sir. 3 ways, sir. Let us say 5 is used here. Then 1 and 3 are available here, sir. This is 2 ways. 3 into 3 into 3, 2, which is 18. You are giving only 18 as the answer. But here 20 available. So 12. 4 into 3, 12 available. Here 4 ways. So 4 plus 12 plus 18, 34. See the mistake. Clearly question not regarding how many 3-digit numbers, how many positive integers. Single digit also positive integer, 2 digits also positive integers. So every question, and still we're actually in permutations also we are not done half also. Why? Because we are still with the numbers. There is a concept called boys and girls alternately sitting. When boys together, girls together, how many ways? Okay, no boys sit together, no girls should sit together, no two girls together, no two boys together. There's a lot to be discussed in permutations itself. Is where a half, when the halfway. Okay. Now this question, that's what I'm telling you. Slowly we'll go for the peaks, next level questions. Now see this. How many 5-digit numbers can be formed using digits 1, 2, 3, 4, 5 and 6 which are divisible by 4 and without any digits being repeated? You should know divisibility by 4 rule. What is the divisibility by 4 rule? Last two digits must be divided by 4. This question without repetition, right? Next we'll solve the same question with repetition, how it will be done. First without repetition, then with repetition, then you'll get better clarity. What is happening wrong? Okay, why this, why that, right? So now 5-digit number, listen my dear friends. Our first focus is on these 2 digits. This is with the concept repetition into mark, not allowed, right? Now first focus on the last 2 places. Using 1, 2, 3, 4, 5, 6, last 2 places can be 12. Is it divided by 4? I'll pick with the combination 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, then 2, 4, then 3, 2, 32, 36, 52, 56, then 64. How many ways I can fill this is now? These two can be filled in 8 ways. Okay, let us say I am taking 36, means 3 and 6 are gone. Still I have 1, 2, 4, 5. 4 digits for 3 places we call 4p3. 4p3 into 8. 4p3 means 4 into 3 into 2, which is 24. 24 into 8 is 192. Option C. See that y 12, 16, 24, 32, 36, 52, 56, 64. See those things. I take an example 36 I am filling, means 3 and 6 is used, then I can use only 1, 2, 4, 5. You can take 24 use, the remaining numbers are available like that. Why 4p3? Out of 6 digits, 2 digits already used. Available is 4 and we have 3 slots, 4p3. Now can anyone say, if repetition allowed, what can be your answer? If repetition is allowed, what can be your answer? This is repetition not allowed. If repetition allowed, yes. If repetition allowed, what will be your answer? We are not allowing you people to discuss among you. If you have anything, please let us know. If repetition allowed, what's your answer? Yes? No need of the calculation, something like 4p3 or like that. If you 4p3 or like that, no, we cannot put if repetition is there, no NPR, right? Never don't say when repetition is there, going for the option 7PR, 7CR is waste. That NPR, NCR will not come when repetition is allowed. Yes, 7, 7, 7 cube. Okay, 7 cube into sir 5, 76 for repetition allowed. No, it's a huge actually. 5, 1728. No, it's still more than that. Wait, 43 into 9. No, it's more than 2700 actually. Listen. Okay, focus. See, first of all, these places, I can write 7 cube. 7 into 7 into 7. 7 are how many? 6 numbers here? 6 numbers, yeah. 6 into 6 into 6, yeah. 7720 is correct. I thought of 7 it is. 6 into 6 into 6. No disturbance. Divisible by 4, those things will not decide. All numbers are allowed there. Then what about this place now? Into those given 1728. Here into what? 8. 9. Into 9. Because 44 allowed now. In those 44 I had not written. Now 44 allowed. 24. We given 32. 36. Now specialty of 44 will come. Previously 44 is not written. Now 44 comes into picture. Repetition allowed. See, that's what the beauty in the concept. Sir, I'm doing mistakes because of that. Don't leave this topic. It's an advanced one, first of all, but still don't leave it. There is a learning. Fine, happy, no problem. Okay, there is this repetition allowed 44. Here, 44 is not kept. Now 44 added. Previously 8, now 9 is the chances. 6 cube into 9. 6 cube into 8, as we mentioned here, it's 1720, but it's more than that. Next one. Are you clear with this question? This question is given in TCS company. See this 11th one. You can search this question in Google. You can find this in TCS. We went to next level now because two conditions I am using. How many 6-digit? Even number. There is one condition. 6-digit. Even number means which position? Units place we need to focus. Rightmost place. Okay. Can be formed using digits 1 to 7 such that the digit should not repeat. Repetition not allowed. There is one more condition at the end. Second last digit should be, means here units place, tens place, both must be even. Repetition not allowed. Now solve this question given in TCS. So what's the answer? 720. Okay. So 6-digit number. So 6 slots. Even number. This one should be even. This one should be even. 1 to 7 means the numbers are 1, 2, 3, 4, 5, 6. Let us say here I should use 2, 4, 6 means 3 ways, and I am done with 6. Let us say, then I should use 2 and 4, 2 ways only. Let us say I am done with 4, 4 and 6 are out. I have 4 numbers. Okay, one more number, 7 also there right here. 5 numbers, 4 slots, 5p4, which is 120. So 120 into 2 into 3, which is 720. Option D. But why 5p4? Why 5p4? 5 digits are available and 4 slots. Right. And why 3 then 2? Some people will argue, sir, I'll go for tens place then units place. Okay. 3 into 2 will come then. Instead of 2 into 3, 3 into 2, that will not disturb. Now same question repetition allowed, then what might be the case? Same question repetition allowed, then what will be the scenario? Previous question, this is the case where repetition allowed we are discussing also. Here also I am doing the same. This is repetition not allowed. If same question repetition allowed, what will be the changes happen? If the repetition is allowed, this should be, yeah, here 3 into 3, superb, because again and again I can use that. Here 1 to 7 all can be used, 7 into 7 into 7. 7 power 4 into 3 square. Repetition allowed means I can use the same digit again. So 2, 4, 6 can be used in that place and this place, so 3 and 3. See the difference now. In fact, repetition allowed is always easy to handle. 7 power 4 multiplied by 3 square. And see this question. Actually, my discussion is bit next level. I'm going with this small question. Three-digit number formed using 1, 3 and 9 without repeating any of them. Okay, what are the digits you formed? You have to do sum of that. Actual question is 5-digit number with different digits. I want to develop a shortcut from this simple example before working for the bigger one. Here this question is 3-digit number is formed using the digits 1, 3 and 9 without repeating any of them. What is sum of all such possible 3-digit numbers? See, so far, how many 3-digit numbers we calculated? Now we have to write all those 3-digit numbers and we need to add all that. We need to add all those 3-digit numbers, summation. That too, this is 3-digit number, but see, my intention is not this question actually. From this, we want to develop a bit complicated thing. This one. This is 5-digit number using 1, 3, 5, 7, 9. Sum of all those 5-digit numbers you need to calculate. The answers also it is in lakhs. 66 lakhs something. Right? So now this is the challenge. Now see this basic question first of all. See first 139 I'll list out, don't worry. 13 without repeating the digits, right? With repetition also we can solve later. In the same way I'm giving the clue in your mind so you start doing those things also. Now 139 is one number. Is it 3-digit number using 139? I can write 193. Other one 319, 391, 913. That's it. These are the numbers which can be formed using 139. Okay, without repetition. Now we have to do sum of this. Right. If you want to do sum, 9 plus 3 plus 1, which is 13, 3. Again 13 means 4. I think 1443 will come. You just check it out. Adding all this, you will get 1443. You check it out once. 12, 21. Sorry. One. 13 and 13, 26. Double will come. 26 there, 28. So 2886. 2886 is what you are getting once you add all that. Rough case 100, 100, 300, 300, 900, 900. Like that also you calculate rough. Okay, rough case you will get close to that. Right. But listen, if this is for 5-digit number, 120 numbers will come. Without repetition, 5 factorial, 120 will come. Writing all 120 numbers and doing summation is a not an easy task within the given time. Well, it is 3 minutes also not possible. Now we need some alternate. What is the alternate? This is original task actually you need to do. But what is the alternate thing? Listen, see if I give directly procedure, you may not agree with that. But my task is simple. Can you see 1 in hundreds place? Among those numbers, one is in hundreds place, one is in tens place also you can see, one is in units place also. Similarly, 3 can be seen in hundreds place, tens place, one place. See, either listen, how I am reading the statement. Listen, how we are reading the statement is important. Either 1 or plus means or 3 or 9 is occupying hundreds place or tens place or once among these three slots, hundreds place, tens place, one place, units place, 1 or 3 or 9 can occupy hundreds place or tens place or ones place. Right, this is 139 into triple one. But listen, it's not done. Guys, see, 1 or 3 or 9 means among that only one digit I am using. 1 plus 3 plus 9 means 1 or 3 or 9. Among those three I am using one digit. Wait, next 100 plus 10 plus 1 means hundreds place or tens place or ones place. Only one among that is filled. Listen, this you have to understand, or else going forward will be a bit tricky. Means this place, let us say I am using 3. Among 139, I am using 3. I fill hundreds place. Now, how many numbers are available? 2 digits are available. How many places available? 2. I should do into 2p2, 2 factorial. 2p2 better. There is extra 2p2. But understand what is the 2p2. Why you remove 3, sir? Well, not only 3, you take one among that. I use one among that digit to fill one among that slots. Because plus is used. Plus means R. Hundreds place, R, tens place, R, ones place. Using digit 1 or 3 or 9. So I'm using 3. I'm filling this hundreds place. Now if you do the 2p2 nothing but 2 factorial 2. You do all this, you will get 2886. You check it out. Okay, for your easy thing, I'm to time save. I'm using the calculator 139 triple 139. No, 1 plus 3 plus 9. See, my blunder. It is 13. Sorry. We have to clear this. Yes, so 13 multiplied by triple 1 multiplied by 2. We got 2088. This is 1 plus 3 plus 9, so not 139. Okay. Now can anyone say if repetition allowed for this question, what can be changed? This is without repetition. This is the challenge for you people now. Listen, same question. If repetition allowed, you write all the possibilities. How many will come, you know? How many 3 numbers with 1, 3 and repetition allowed will come? 27 will come, 3 cube. Triple one, 133, 199, 113, all 29, 27 houses are 3 into 3 into 3. First place 3 ways, tens place 3 ways, units place 3 ways, 3 into 3 into 3, 27. You write all the list. What is the answer you are getting there? And I am showing you right now, if repetition allowed, only one change going to happen. 1 plus 3 plus 9, yes. Here, hundreds place plus. Among these 3 slots, one slot is booked. But when repetition is allowed, all 3 numbers I can use. This should be 3 square. Remaining 2 slots can be filled in 3 square. That's the only change. There 2p2, here 3 square, 3 into 3. Why, sir? In repetition, all digits can be used again. Previously, I into mark 3 means I used one digit, but now in repetition mode, all 3 are allowed. Why 3? Only 2 times here I written 3 into 3. Why only 2 times? Because one place is already filled. Either 1 or 3 or 9 used to fill one among this place. That's what. Please understand the method. Okay, don't by-heart it. I given you a challenge. You try writing all 27 numbers using 139 on paper. Use calculator, do summation, and check this. Both will be equal. Okay. Now, what will be this question now? 13579 without repeating any of them. 13579 5-digit number without repeating any of them. What is sum of all such possible 5-digit numbers? Yes. Without repeating any of them, what is sum of all such possible 5-digit numbers? Now, what you should do first of all, one, this is repetition, not allowed. 1 hour, 3 hour, 5 hour, 7 hour, 9. Okay, I am writing 5 ones directly. Why? 10,000s place. Yeah, 5-digit number in fact. 10,000s place, thousands place, hundreds place, all that. Okay, as this 5-digit number, I am writing 5 ones directly. Or else we can expand. Previously 3-digit number 3 ones came. Right. Now, among those 5 slots, one slot is booked and one of the number is used. Let us say 5 is used. Then how many slots are available? 4 slots. How many numbers are available? Now, what is the way to fill? What should be written here? 4 P4, 4 factorial. Repetition not allowed. Now, same thing, repetition allowed. What can be done? 1, 3, 5, 7, 9, 5 ones, 5 power 4. 5 into 5 into 5. All 5 digits are allowed and 4 slots are there. 5 power 4. What about the calculations here, sir? 25. This is 5 ones into 24. 4p4 means 4 factorial 24. 600. So 66600 will come in, right? 25 into 24 is 600. 2 zeros ending. Multiplying that with 6 will give this. 66,66,600. But now I am going for one more question. Listen, why only 5-digit number, 5 digits only given? Previous question, 1, 3 and 3 digits are given, 3-digit number. Why can't they give 5 digits, 3-digit number asking? Is it possible or not? Can't they ask 3-digit number using 5 digits? They can ask, right? See, this question completed, then don't throw it out. You think about what's the new possibilities. This question easy because I am telling you 5-digit number and 5 digits are given. Previous example also 3-digit number, 3 digits are given. But my next question is, see, how many 5-digit numbers is formed? Now directly write your answer. What can be the case? 5-digit number formed using the digits 1, 3, 5. 6, 7, 8, 9. Digits given are how many? Not 5 now. I given 7 digits. But don't worry. Don't worry. Yeah, first of all, let me know what's the thought going on your mind. I want 5-digit number using 1, 3, 5, 6, 7, 8, 9. Without repetition, then with repetition also will do. There is nothing going wrong for us. Good next level question this is. Listen, 5-digit number means 5 slots. Guys, see. I am giving you few examples. This 5-digit number can be 13578. Can I write like that? Is that a 5-digit number formed using given digits? Yeah. I can write 5-digit number is 5178, 51769. Is this a 5-digit number? Listen, when they given more numbers also, all can be used. I can use 8 and 7 at the hundreds place. I can use 7 at the tens place. I can use 7 at ones place also. This is few examples. What you can do is write all the numbers. Now you people will get doubt. Sir, they given only 5-digit number, but you are writing all the 7. How this is okay, sir? What's our meaning? 1 hour, 3 hour, 5 hour, 6 hour, 7 hour, 8 hour, 9 is going to occupy 10,000 place, thousands place, hundreds place, tens place. And why 5 ones? Why not 7 ones? It's a 5-digit number. Right. Okay. Now, into what should be the last one? Let us say this slot is filled using 5. Then how many digits are available? 1, 3, 6, 7, 8, 9. 6 digits available. How many slots? So 6p 4. Now guys, please help me. If repetition allowed, what can be done now? This is repetition not allowed. Same question, repetition allowed. What can be done? Yeah, 1, 3, 5, 6, 7, 8, 9 into 5 ones. Yes. Into 7 power 4. All 7 can be used. In repetition not allowed, 5 used means 5 gone. But here I can use 1, I can use 3, I can use 5, 6, 7, 8, 9. See the difference. This is what learning the concept. This generally, this last 2 questions itself will take more than half an hour generally. But once you understand, if you have a doubt what you should take 2-digit number using 3 digits, right? Practically, if you want to clear the thing, okay, you take 4 digits, 1, 3, 5, 7. I want 2-digit number, write the entire list manually and try this method. 100% will work. Whenever you want to create the new ones, go with the small, understand, apply the logic for the big one. You have to develop the big things like this. Right.